This is the bicycle frame that I totally designed myself to be as easy as possible to manufacture and fabricate in my garage out of 2-inch OD tubing and 1-inch OD tubing. Everything is cut with a hole saw, miter saw, basic tools like that. A few custom parts like this head tube, the bottom bracket shell, I made on a lathe, and then the flat 2D parts, these brackets and the dropouts, I had water jet cut by an outside vendor. This model includes the chain ring in the front and the cassette, and I planned out where the line of the chain would be to avoid any interference with the bars down there, and I dimensioned everything overall in terms of some basic parameters that I got by measuring a bike that I already have and tweaking a few things here and there that I thought I didn't like about that bike. So I basically set things up in terms of the wheelbase, height of the cranks above the ground, tire diameter, things like that. I got some of these values are just kind of typical for what a road bike uses, like this caster angle. This dimension here is based off what my fork is going to be and some of the parts that I knew I was going to use. But overall, I designed this primarily to be a road bike. I'll put a little bit wider tires on it so that it can handle some gravel trails here and there. But this is the extent to which I designed it before I started actually cutting anything at all. I made these dropout plates as a separate part made out of steel, stainless, 316. I did that because I was concerned about fatigue in this area. Aluminum does not have great fatigue strength, and every pedal, every push of the crank is going to kind of make the axle cyclically press in this area, which is definitely causing fatigue to be a concern there. And also I predicted that I would have some trouble getting all of these welds and angles to match up just right to get the rear wheel perfectly straight. So having that be a second separate part lets me detach it, iterate it, and replace it without needing to cut and re-weld anything on the actual frame. I did not do any kind of FEA or anything like that before I started building this, but I'm kind of going with the overkill method. These tubes are kind of significantly larger and thicker than what a bike like this would typically use. I made all of this out of aluminum 6061, which is pretty easy to cut and fabricate with, and I should note that I don't really know how to weld. I did this project mainly because I wanted to learn, and it turns out a bike frame is a very difficult thing to make as a first welding project. Also, I made drawings of each individual part, which I'll quickly go through. These are not really meant to be complete with everything you need to manufacture this, but since I was making all of this myself, I mainly just included dimensions that were going to be helpful and make sense to me. Most of the cuts and things I dimensioned based off the center of the hole saws that I'd be using and the angles I was going to put my jig at, and I didn't include very many tolerances because realistically I wasn't going to hit any tight tolerances making this stuff. I added tolerances here and there on some of the parts I would make on a lathe just so I know what's going to be needed to get the fitment right. This is all the stock I'm going to be using. I got 12 feet of 2-inch OD and 12 feet of 1-inch OD, both 1/8 inch wall thickness. Printed out all my drawings and just marking where my cuts are going to be. This is my tube notching setup. It's a Harbor Freight tube notcher jig with a hole saw on it. This aluminum is pretty easy to cut, and I'm just using a tiny bit of WD-40 as a lubricant. The hole saw does actually bottom out on the top here without fully separating it. If I do a full diameter like this, when I did a half cut off the edge on the other side, that didn't happen because it separated there. So on future cuts, I'm just gonna cut it down the center with the miter saw first and then do this. But in this case, I'll just flip it over and drill from the other side. So that works out fairly well. These really thin walls on the tips that it leaves are because the hole saw is exactly the same diameter as the tube. So I'm gonna grind down those really thin parts off of there. Next, I'm gonna cut these angled reliefs, if there are any. And those are always oriented such that the cut line goes exactly through the hole center. So all I have to do is make sure the angle is set correctly and that the cut passes through that center point. Angles less than 45, like this 29-degree angle, will have to come perpendicular on my saw like that because of the limitations of its travel. And without a great way to clamp this, I'm just gonna try freehanding it and see what happens. The offcut was kind of violently ejected across the room at the end, and after looking that over, I think what happened was I finished the cut, I let go of the trigger, and then started pulling up, which is when it happened, but the blade was still spinning. So I think that gave this room to move slightly, and then the blade just dug into it weird, jammed up, and just sent it launching across the room. So next time, if I don't have a good way to clamp it down for a sharp angle like this, I may just make that cut by hand with a hacksaw. So by doing the hole saw cut last, I leave this flat face as a datum to line up as the center hole of the hole saw cut, and I can also use it to line up the angle cut and measure the overall length easily. So I'm basically just conserving the center point of the circle on the part to use as a datum for all the other cuts. And here we have the final geometry for the end of this part. As I noted on the drawing, I plan to either file, Dremel, or maybe miter saw off that last little sharp there just to clean that up. Time to prevent sending this piece to space, I made most of the cut on the miter saw, and then I'm just gonna finish it on the hand saw. So that worked out just fine. The rough hacksaw part will actually just be taken out by the hole saw cut anyway. So since I designed it such that the center line of this hole intersects the central axis of the tube on the end of the flat face that I've already cut and using as my datum, I can line up my tube with my mark line at a 90 degree like this, and then I can rotate it to my nominal 58, and I'll get that hole in the right position along the pipe. So I was wrong about that alignment, and I've just readjusted a little bit accordingly. Actually, this jig rotates the pipe about that bolt as a pivot point, and that bolt is not collinear with the central axis of the drill where the center point of my hole should be. And based on the length of material here and the length of the saw, I expect this one to bottom out. So I'll either kind of help it along with a hacksaw or maybe flip it over and do the complementary angle from the other side. So I was about to run into the issue of the hole saw running into the clamp here due to this extreme angle, but then I realized that I actually screwed this part up, that 58 degrees is relative to the parallel, not the perpendicular. So I should have had this gauge set to 32 degrees. It does still bottom out on this top edge, so I'm gonna have to chop off the offcut with the hand hacksaw like before. That was the trickiest part so far, with a couple of off-angle cuts. I just need to shave down these thin areas and then that'll be ready to go. But here's the 58-degree side and the straight side with the relief cut. Here's an approximate mock-up of how the main frame pieces are going to go together. I'm just checking that I cut all my angles correctly, and it looks like I did. To cut these slots that these plates will live in, like so, I'm using an angle finder on this back flat face because that flat cut will be in plane with the slot cut. So then I marked with a center punch and punch 2 marks on either side. Then I'm going to drill through with a 1/4-inch drill bit and use a hacksaw to mate the drill bit hole. And lastly, I'm just gonna file the edges down a little bit to make sure the part fits in through the whole slot. I 3D printed these little fixtures, which I'll screw down into the wooden base to hold all the tubes while I'm tack welding them. I don't think the tack welds will cause enough heat to melt the plastic initially, because they'll be quick and not right up next to it. But I only need it for a single use, and hopefully by the time it does start deforming, the parts will already be bonded well enough. I've got everything fixtured in place and ready to tack weld. I put all these pieces of aluminum foil between the printed fixtures and the actual parts just because I know these are gonna start melting, and that'll at least keep the mess off of my parts. So the fitment turned out pretty well everywhere except this one joint. I've got a bit of a gap. It's not so bad that I can't fill it in with weld, but I think that's just due to the imperfect nature of the way I was doing these cuts and my limited precision. There was bound to be a gap somewhere. That's about 1/8 of an inch at the worst. These weights are just to prevent my plywood from flexing and keeping it flat on the concrete as like a flat datum, because I've got the lower face of this piece flat against the plywood, And then the height of all the other pieces are such that the tubing is exactly centered vertically on this tube. So now all the joints are tacked with a few welds that I will not zoom in on, and I'm going to flip it over and do the other side. So now that everything's tacked, I'm just checking all the parallelism and the straightness to make any tweaks that are necessary before I fully weld anything. And the first thing I'm looking for is parallelism between the seat tube and the head tube. So if I assume my concrete floor is flat and level, and I look close down there, it's a very slight gap on the far edge facing this way. And this side, it's a very slight gap on the far edge facing that way, but there's not a difference in the gap on the sides compared to the other side there. So I know they're kind of slightly tilted into each other, but they're not going off like that, which is good. Now I can just barely tell visually, but the bottom bracket shell is slightly out of perpendicular with the plane and the rest of the frame. A straight edge right up against this face goes very close to the head tube on that end. And on this side with the straight edge lined up, I've probably got a little over an inch of clearance over there. So I put it in the vise and I just kind of pulled on it until I felt one of those tacks give a little bit. So now I'm gonna check it again. So now that gap's at about a 1/2 inch on both sides, and I'm gonna tack it a little bit tighter. I should note that I did check it on this axis also and make some slight tweaks. Cutting these V's that I made the jig for, which only has to hold up for one more cut, but I wish I'd made these slots go further down, almost all the way through the part, because I really need to go a little bit deeper than that and ideally have them converge, which is hard to do without just sawing right through it, but I may just drill the last part out. So the geometry did not work out that well for this. In order to be at the right angle, my 163, I have to leave quite a gap there, and that's because I had it in my head that I could get the bottom of this cut down to 0 thickness, like a perfect V shape like that, which didn't really turn out to be feasible with these jigs, so I'll have to think about a better way to do that. Remade the jig. The problem on the first one was just a mistake in my CAD model. I had drawn the dimensions of the triangular cuts relative to the outer diameter of this instead of the inner, like I should. So once I fixed that, that produced a much better fit for this 15-degree angle. So to position the jigs, I'm just sliding them down even with this mark that I put, measured relative to the correct point of the V-cut. And then I'm using the angle finder on this flat reference surface to make sure that's perpendicular to the flat on this. Once I reached the bottom of where the jig was, the cuts themselves are now deep enough to easily keep the saw close enough in line, because it is pretty close to the end. And these two will converge right near the bottom of the part. The one that I screwed up, the convergence point would have been actually off the part, which is why I had to stop before I got all the way through. Here's what it looks like immediately after finishing that cut. And then I can literally just, boom, there we go, perfect. Now I've put a tack in the corner to rigidify each of these parts, and I think I'm gonna weld them all together as a sort of subframe, and then attach that to the rest of the main frame. But I'll just do a tack here and there until it's all together in case I need to bend or tweak anything, and then I'll really weld it together. For all of this, I'm just carefully clamping them to the table after manually aligning things and then slapping a tack weld on them. Next, I tacked on the Dropout mounting plates, and those are a tight enough fit in the slot that I don't really need to clamp them. They just stay in place really well once I position them. So I'm gonna slide them into the slots on the seat stay, and then I'll have the whole rear subframe tacked together. All tacked together, and that will go something like that. It's important that these two flat parts are parallel because that's what the brackets that the actual wheel mounts to are gonna be on. So that'll make sure the wheel stays straight and in line with the rest of the bike. So in order to make sure these are all square, I'm going around and measuring them in different places, outside to outside. It's 6 inches there, 6 inches there. So just by taking that measurement in lots of different places, I can see if I need to tweak it a little one way or the other. Notches line up well enough that I can actually just hold this part with one hand while I tack it with the other, and it kind of indexes itself into the right angle, so I don't need to worry about alignment as much for that yet. Of course, after I tack it, I'll check everything and bend it one way or the other if need be. So everything's still only tacked in the rear, but that is starting to look like a bicycle now. From this perspective, it does visually look nice and straight, but I do want to find a better way to measure that quantitatively. Maybe I'll see what I can do with a laser level or a plumb bob or something, because I really want to make sure that the mounting location that the rear wheel is going to index on is going to be in plane with the front steering axis. I've hung a plumb bob through the center of the front steer tube, and since that's a circular cross section, it should find its way to the lowest point there if I wiggle it around a bit, because it is slightly at an angle. So I'm marking where the plumb bob ends up and using a straight edge to mark the straight lines parallel coincident with this flat face. That weight's just to hold it down, and then I'm also tracing against the flat faces here. These long lines are the interfaces that the wheel dropouts will mount to, and these measurements and tracing show that the bottom bracket where the pedals and cranks are is pretty nicely centered between those and pretty nicely straight and parallel with it. The concerning part, that X is where the plumb bob was sitting, so this would suggest that my head tube is a little bit out of center of the rest of the plane of the cranks and rear wheel. Measuring like this with the plumb bob does not do anything to tell me about the angle of the head tube, but it does suggest that it's slightly off center one way because it just projects it straight down. I noticed that when I don't have any weights on it, one of these brackets sits a little bit off the ground when the other's on the ground, and both sides of the bottom bracket are on the ground. So this is a little bit higher than the others. I can pretty easily correct up and down error because the dropouts themselves are adjustable. I'm gonna try to measure this again to see if the head tube is centered when it's just resting on the bottom bracket shell down there. Realigned everything, this time only weighted on the one side so that this is off the ground and this is perfectly flat, using that as a datum. And it's lined up to the original Sharpie marks as best as I could, repeat it to this garage metrology setup. But now you can see that plumb bob is much closer to that center line, probably within a 1/16 of an inch or so. So that gives me confidence in the alignment of the head tube, the bottom bracket, and the dropouts. The only slight issue is that one dropout is a little bit higher than another. After grinding and redoing these welds a couple of times, I'm testing the fitment of my dropout brackets, and there is enough room to put all these 3 bolt heads side by side, but then there's not enough clearance to actually get a socket or a wrench on any of them. So that was a little bit of a failure to design for assembly. This is my first time fitting the rear wheel on the actual frame, and something was a little off with my spacing. I don't know if the welding kind of pulled the 2 sides in towards each other, or if I had bad measurements for the width of the actual wheel. But initially I'd planned for both of these brackets to be on the inside, but it was quite a bit tight. I could make it fit if I kind of spread them and it was under tension, but actually moving one to the outside made it fit a lot better. And it's actually a little bit more centered than it was before. Initially, it would be kind of tweaked over to the left a little. I'll have some adjustments to make on the spacing of things, but that kind of happy little accident actually works out a little bit better. The problem is now I won't have clearance when I mount my brake rotor. It'll run into the frame in these bolts. I'm iterating my dropout part by 3D printing it to test fit the geometry, and that's going to account for the error in my frame so that I can adjust it and get the wheel as straight as possible. After a couple tweaks and reprints on that part, I've got this wheel about as straight as I can possibly get it. The last few things I did to the frame off camera were weld the seat post adapter in, and then I made a short little bar there, which I welded on to mount my rim brake to, because the disc brake I originally planned for wasn't gonna have enough clearance. And I tested the whole cassette, chain, gear shift assembly before I fully assembled anything, just to make sure that the chain would clear in every gear, which fortunately it does. It gets pretty close on the highest gear. But after I checked that, I fully assembled everything off camera, because this video is not really about assembling components, but now it's ready for test riding. Also, I remade this dropout bracket to account for that height issue and slight misalignment I discussed earlier. So that's why this looks like it's a little bit off center from where I originally planned, but the rear wheel alignment is much better this way. Riding this bike feels pretty good. Nothing's loose or sloppy. I don't notice any flex anywhere in the frame. It rides pretty much like a normal bicycle, which is good. Once I got everything, the seat and the handlebars adjusted to my liking, I'm pretty happy with the way that it handles. After about 10 or 15 miles with no spontaneous, unscheduled disassemblies, I would call that a success. I'm pretty happy with how it turned out. I think if there was going to be a catastrophic failure somewhere in the frame, it probably would have happened by now, but I am going to leave it unpainted for a while so that I can easily inspect all the welds and the joints and keep an eye on things. But that'll conclude this video, so thank you for watching.